Ну, да. So, dear colleagues, let's continue our school with our next lecturer, Ilya Afanasyev, from the, how it's called correctly in English. So please tell some words about you.
Good afternoon, dear colleagues. My name is Ilya Afanasyev, and I am delegate from Russian regulatory body. It's Rostekhnadzor, Federal Environmental, Industrial, and Nuclear Supervision Service. And my lecture, Regulatory Framework for Nuclear Facilities Decommissioning in Russian Federation. And first of all, we should find out what categories of nuclear facilities exist in Russian Federation. And according to the federal law of Russian Federation on atomic energy use, all nuclear facilities in Russian Federation are divided into three main categories. The first is nuclear installations, and this category includes structures, complexes with nuclear reactors. The next, industrial, experimental, and research nuclear reactors, critical and subcritical nuclear assemblies, and other structures, complexes, and installations with nuclear materials intended to the production, use, processing, transportation of nuclear fuel and nuclear materials, and installations and devices with nuclear charges for peaceful use, for instance, for mining purposes. The next category, storage facilities, such as stationary facilities and structures intended to storage of nuclear materials and radioactive substances, storage or disposal of radioactive waste. And the third category, radiation sources. It's complexes, installations, devices, equipment, etc., which contain radioactive substances or generate ionizing radiation. And it's not related to nuclear installations. And particularly, I'd like to note nuclear materials. This is materials containing or capable of reproducing fissile nuclear substances. And you can see these all categories. On this scheme, you can see the main stakeholders in atomic industry in Russian Federation, and red color represents government authorities. In the center, you can see bodies of state regulation of safety in the use of nuclear energy. And for example, my organization, Rostekhnadzor, it's here. And you can see government of Russian Federation and international organizations, for example, International Atomic Energy Agency. Operators are here. And you can see that Rosatom controls all activities related with radioactive waste management. And in Russian Federation, we have the only one organization which is authorized to radioactive waste disposal. Its name, National Operator for Radioactive Waste Management, and it's under the authority of the state corporation Rosatom. And if you want, you can take my presentation, which is printed, and you can see this for free. Maybe it will be convenient for you. And the next slide, it's a structure of the documents in the field of atomic energy use. And you can see international agreements, Constitution of the Russian Federation, federal laws. It's a top of this structure. The main federal laws are on atomic energy use, 170F Z. The next on radioactive waste management, on radiation safety of the population, on environmental protection, etc. The next level is decrease of the president of the Russian Federation and decrease and orders of the government of the Russian Federation. And the bottom level, acts of federal executive bodies. For example, Rostechnadzor. And we develop federal rules and regulations in the field of atomic energy use, and we call it NP. And we develop safety guides for the use of atomic energy. And other government bodies, for example, Rospotrebnadzor, you can see it here. It develops sanitary and epidemiological rules and regulations and hygiene regulations. I hope that you understand this information. The next. This slide about our federal rules and regulations and safety guides. It's the most important documents in atomic energy field in Russian Federation, and in accordance with federal law on atomic energy use, safety requirements for all nuclear facilities and for activities in the field of atomic energy use, including goals, principles, and criteria for safety, are established in the federal rules and regulations, which are mandatory for all persons and subjects carrying out activities in the field of atomic energy use on the territory of Russian Federation. And maybe you know, it's an analog of safety requirements in International Atomic Energy Agency. And in accordance with degree of the government of Russian Federation, Rostechnadzor is only one organization authorized for development, approval, and commissioning of federal rules and regulation and safety guides. And I should notice that the reason for refusing to issue a license may be the non-compliance with the requirements of the federal rules and regulations. In order to promote compliance with the requirements, safety guides approved by Rostechnadzor, and they are containing recommendations for fulfilling the requirements of federal rules and regulations, including methods for performing works, techniques, etc. And these recommendations could help operators for compliance with the requirements. It's an analog of safety guides in Atomic Energy Agency. This is a structure of federal rules and regulations. And you can see on the top level, NP 091. It's a general provisions for ensuring safety, containing general provisions during the decommissioning of all categories of nuclear facilities, excluded spacecrafts, radiation sources, and radioactive waste disposal facilities. The next level, it's a general safety requirements. It's analog GSR of International Atomic Energy Agency. And they establishing safety requirements at all stages of the nuclear facilities life cycle. And they include a number of general safety requirements for the decommissioning of specific categories of nuclear facilities. For example, you can see NP 001 for nuclear power plants, NP 016, it's requirements for nuclear fuel cycle facilities, etc. The next third level It's a federal rules and regulations establishing safety requirements for the decommissioning of specific categories of nuclear facilities. And it's a specific requirements only the decommissioning stage. And the next level, it's a safety guides. You can see a lot of documents, and these safety guides cover all nuclear facilities and safety aspects. All these documents are on our site in internet. You can check it on the secnrs.ru, and you can download all these documents. And I think a lot of all these documents in English. On this scheme, you can see nuclear facilities decommissioning planning process in Russian Federation. And you can observe that it's analog of International Atomic Energy Agency approach. And you can see all stages of a life cycle. For example, sitting, design, construction, operation, transition phase, and decommissioning. And an essential part of decommissioning planning is record keeping. You can see it this. And all operators should maintain of the nuclear facility decommissioning database during all stages of life cycle of nuclear facilities. This point. And a lot of information from characterization, for example, and radiological service, etc. You should upload in this decommissioning database. And now my radiation safety division, along with Rostechnadzor, is developing new requirements for decommissioning database maintaining. And let me introduce the conceptual scheme of database maintaining. For example, at the nuclear facilities design stage, all operators should develop a building information model, BIM, maybe you know this, and integrate it into a decommissioning database. And before the decommissioning stage and before decommissioning works, building information model should transform into nuclear facility digital engineering and radiation model. And we call it DERM. And this model will be contain results of comprehensive engineering and radiation survey or characterization. And you can see this model here. And this nuclear facility digital engineering and radiation model, it's a part of the decommissioning database, which is developing at the stage of preparation for nuclear facilities decommissioning. I hope it's not difficult for you. Okay. And now I want to tell you about decommissioning concept. It's a special document which we use in Russian Federation. It's an analog of initial decommissioning plan in Atomic Energy Agency. And this document It's a main document of the nuclear facility decommissioning planning process, which should contain organizational and technical design solutions aimed at safety of decommissioning of nuclear facility. For example, possible options for nuclear facility decommissioning, decommissioning strategies, and a description of the planned end states of the nuclear facility. The next selected option for nuclear facility decommissioning, criteria and justification for its selection. The third is assessment of the total amount, mass, volume, type, category, class, and activity of radioactive waste generated during decommissioning of the nuclear facility. The next decommissioning concept includes list, description, and sequence and preliminary schedule of the main activities to prepare for the decommissioning and decommissioning of the nuclear facility. The next is measures to ensure safety in the management of radioactive waste generated during decommissioning, including measures for the radioactive waste removal from the facility site for storage or disposal. And the next point, it's a list of conditions for necessary revision of the facility decommissioning concept. And the last point, it's a procedure for maintaining the facility decommissioning database, including techniques and methods for recording, collecting, and storage of data necessary for decommissioning. And all recommendations for development of decommissioning concept are in these safety guides, which named RB 153 and RB 008. And these documents are available in our website. What's the aims of decommissioning concept development? The first aim is a selection of nuclear facility decommissioning option or decommissioning strategy, development of appropriate design solutions aimed at its implementation, and assessment of the cost of decommissioning works for the selected strategy. And for example, there are three main decommissioning strategy. It's immediate dismantling, deferred dismantling, and entombment. And entombment is not preferred strategy, but for specific objects, it could be convenient. The next point or the next aim is establishment of responsible persons, update periods, methods, techniques for collecting, processing, saving, and protection of the records and data significant of decommissioning. It's about decommissioning database. And what is decommissioning database? It could be paper data, paper and digital data, and centralized IT system. And the next aim is determination of the necessary measures for safety of radioactive waste management during nuclear facility decommissioning, including identification of required radioactive waste containers and radioactive waste disposal facilities. And you can see the small scheme of the life cycle of all facilities. And decommissioning concept is the important basis for the next documents. It's a decommissioning program and decommissioning project documentation. And now I want to tell you about some recommendations on decommissioning concept development, which is included in RB 008. Decommissioning concept should include 5 chapters. It's a introduction, the input data, decommissioning options, works on decommissioning preparation and implementation, and updating the decommissioning concept. You can see it here, the main chapters of the decommissioning concept. And these main parts includes this information. For example, list of tasks solved by the decommissioning concept, analysis of possible impact of the nuclear facility decommissioning on other nuclear facilities, list of legal acts taken into account in the decommissioning concept, characteristic of the nuclear facility and its site, information sources used in the decommissioning concept. The next is information about the decommissioning database maintenance. The next is design solutions aimed at nuclear facility decommissioning, list and description of various decommissioning options, selected decommissioning strategy, list of works on decommissioning preparation, sequence and interdependence of decommissioning works, estimated decommissioning works duration, scheduled decommissioning concept updating periods, conditions for an unscheduled decommissioning concept updating, and information and reasons of changing of the decommissioning strategy. And this safety guide includes some appendices. For example, appendix second, third, etc. And the appendix number 2, it's a structure and contents of the decommissioning concept at various stages of nuclear facility life cycle. And it shortly describes each chapter of the decommissioning concept at various stages of nuclear facility life cycle. Appendix 3 presents a recommended list of the records and data that should be included in decommissioning database. Appendix 4 presents a recommended list of works of nuclear facility decommissioning preparation and implementation. And appendix number 5 indicates factors that are recommended to be taken into account in the decommissioning planning process, including works for the removal of nuclear materials, spent nuclear fuel, and radioactive process mediums from nuclear facility equipment and systems. And the next main document, it's a decommissioning program. It's an analog of the part of the final decommissioning plan. It's an organizational and technical document which should contain the main decommissioning activities in accordance with the selected decommissioning strategy, and procedure, conditions, and planned schedule of activities of preparation and implementation of nuclear facility decommissioning. This document is not decommissioning concept, because decommissioning program, it's really working document which we developed before decommissioning works at stage for operation. For example, transition phase. On the transition phase, every operators should develop this decommissioning program, and this decommissioning program includes description of changes in nuclear facilities operation conditions after final shutdown, including a list of systems elements for which the operating regulations are changing. This decommissioning program also includes sequence and preliminary schedule of implementation of the nuclear facility decommissioning stages, scope, methods, and schedule of the nuclear facility comprehensive engineering and radiation survey or characterization, and organizational structure of management of nuclear facility decommissioning preparation and decommissioning implementation. And decommissioning program includes description of the nuclear facility decommissioning database, including methods and tools for information storage. The next point is brief description of the planned final states of nuclear facility after completion of each decommissioning stages, and conditions and procedure for making changes to the nuclear facility decommissioning program. All recommendations are in these documents, which you can see on this slide. For example, RB013, it's for nuclear power plants, and RB105, it's for ships with nuclear reactors. And that's all. Thank you so much.
Okay. Any questions? Actually, I have one about this database DERM for the decommission. Yeah, who is responsible for this database, or who is operator of this database?
All responsible for safety of nuclear facility is operator, and this model could be developed by operator or another organization по заказу оператора.
In order. Okay. So, but is there any, let's say, universal platform for all these databases?
No, it's a conceptual approach for now, but some organization in Russian Federation could develop these models, and we hope that all operators can develop this model by themselves, because this model use unique general formats. For example, IFC format from building engineering models.
Okay. Does your organization is planning to, let's say, have all these databases as a main safety regulator? No?
I didn't understand your question.
So, I mean, if any of the facility or operator will have these databases, does the either Rostechnadzor or your center, scientific center, planning to have all these databases?
We don't have all the decommissioning databases from the operators because they have their decommissioning databases on their computers and their bases.
Okay. So.
But we check these decommissioning databases before give them license.
Okay, I see. Thank you. Any more questions? If not, then let's thank the speaker again. Thank you.
Thank you so much. And you can take the presentations too.
Ну, у нее кармашек есть. Там есть PDF-версия, что вам
Мы спустили, то есть и посерединке класс.
Отлично.
So now we continue with some technical details on the decommissioning, in particular the use of the digital technologies for the radiochemical facilities, characterization, also including the decommissioning stage. So please, Ekaterina, start.
Thank you very much. Good afternoon, ladies and gentlemen. Today, I represent my company, Neoland Group of Companies, and I'm responsible for universities and public relations of my company. And today I want to tell you about some digital tools provided by Neoland Group of Company. Briefly about us. Neoland is IT and engineering company, and we develop software to support nuclear power plants and facilities and the life cycle, and during the most important and serious stage, decommissioning stage. And I wanna tell you today and show some practical cases. And at the very end of our presentation, we would like to demonstrate you a little practical example. So let's start. There are three main radiochemical plants in Russia, in Ozersk, Seversk, and Железногорsk. So all the facilities have the same challenges. Maybe you know the serious challenges, lack of documentation, complexity, and contamination risks. And of course, a huge amount of documentation. And as you know, decommissioning activities consist of 5 measure points: planning, characterization, decontamination, dismantling, and management of materials. And if we talk about all stages, the most serious stage is the second one. It's characterization. Can you imagine that we have to work with a huge amount documentation to support this stage? We have a lot of procedures for process and collect all engineering data. Then we have to obtain actual engineering configuration of the facility, and then we have to perform material inventory. After this, measure and calculate radiation amount to categorize them prior dismantling. So it's quite impossible to imagine all these processes without appropriate digital tools. Here we can see the general stack applied digital technologies, what we use in our practice to perform characterization. The core of technologies is building information modeling. BIM model is multi-purpose digital environment and contains structured engineering data. It enables to develop and applicate different additional specialized tools for characterization process, radiation calculations, and general analytics. And other important technology is automatization, data capture tools, and we will talk about it later. So BIM model is a digital representation of 3D configuration of facility systems, structures, and components combined with structured attributive data, other important information, and connected documentation. The average BIM model, maybe you know, maybe not, of a nuclear power plant consists of more than 300,000 elements and more than 5 million attributes. All these elements and attributes are essential for decommissioning purposes. Just imagine how it's possible to manage all processes or elements, attributes without proper digital tools. Usually BIM model is developed during physical characterization of a facility. Performing a radiological characterization requires another set of technologies and procedures. So we start from preparation and initial analysis, and we go to simulation and safety estimation. And I will show you step by step all these processes very briefly. Preparation and initial situation analysis, it's quite obvious that the final goal of radiation measurement is to obtain data for subsequent calculations carried with BIM integrated digital tool. Here the most essential is to define the number of positions for measurement points. If you see on the screen. Maybe you can see on the screen the yellow points, like measurement tools. To do this, we use simplification of BIM elements. So we simplificate equipments, tubes, cables, constructions by their representation as geometrical objects, cylinders, spheres, flat barriers, which we call phantoms. Then a characterization specialist makes hypotheses about the radiation sources location in a given BIM model area. So we have 3D phantom model with phantoms defined as radiation source and phantoms defined as a barrier. Then the measurement points are set in the BIM model. Their location depends on the type of measurement, for example, dose rates, alpha, beta, or swipe sibling. Points location is secured by coordinate system inside the model and also linked to surrounding phantoms for better in-field positioning of equipment. And then we are planning the characterization tasks to give to our team of specialists. And the task includes dose rate measurement, alpha or beta counting, gamma spectrometry. So we should be aware that our specialists will perform the measurement exactly. And in our work, we use special devices. We use special devices like tablets and it's industrial tablets with preloaded 3D model of the area, measurement points, their location, and measurement task. And every specialist is making measurements, photo of the system, structures, components. It's very important for further decommissioning planning in case of metal corrosion or equipment destructions. And all the collected data transfers from mobile devices to BIM model. Here you can see an example of BIM model of a certain area fulfilled with measurement points. You can choose any point and in the model and check the corresponding measurement result. Then using analytical tool, you can generate the radiation survey report. You can see it here, a very, very detailed one. And then we go to calculations. We use two types of calculations. We call it inverse task and direct task, direct one. Solving inverse task, you can find the specific activity of phantoms and beam elements by using the geometry, material composition, and find the result of those rates measurement at all measurement points in a given area. All calculations of the specific activity of each phantom characteristics attached in every beam element as attributes. And now we can calculate rate waste and divide two categories. So here you can see the different levels of categories. Raw could be estimated by amounts and categories. And here we can see the categories and amounts, volume, weight. And if we talk about categories by level, they go from very high to very low level. And the final report could also be generated and attached to the commissioning plans. Here we can see this final report, a little piece of report. After we know specific activities of all systems and structures, we can calculate the direct task, which is to find the dose rate volume distribution using the meaning of specific activity of elements and their 3D configuration in the given area. These calculations are very important from radiation safety planning and management point of view. And on this slide, you can see an area with calculated dose rate distribution. And we can see from this step by step, the distribution changes along with dismantling process. This algorithm provides engineers with a necessary tool for radiation safety management and other simulations. And at the very end, we can At the very end, we have automatically generated physical and characterization report in the given template. And I will show you some practical cases of a Nyaland company. As I said, knowing the exact amount of RAW, we can simulate the decommissioning stage. Also, using digital technology, we can reduce the number of personnel, reduce costs, optimize costs, and accumulate knowledge from one generation to other generation. So just imagine that without digital technologies, it will be a work of 100 people, because you see how many documents we have on the screen and how many work it would be for people. Engineering data stored in a single digital model eliminates mistakes, and all participants can see the same verified data, and you haven't to run between departments, between cities to verify this data and coordinate this data. Here you can see Nyaland's reality capture technology. We call it NordLS. The process consists of 3 stages. At the very beginning, the special device scans the area. When we load the result, recognize the measurement points and clouds with the help of our technology. And finally, we complete 3D model. We call this process digital archaeology. On this slide, we can see reality capture result of the radiochemical facility. It's more than 2,000 points and 3,000 spheric panorama, not only inside, but also outside of this facility, as you can see on the screen. When our 3D model is ready, we can navigate between different levels. You can see on the screen that we can navigate between buildings, compartments, and equipment. We see different levels. And here we can see the detalization comparison. We can compare result based on documentation here as is BIM, and the 3D model after with photographic view after the work of our technology. So this slide is very important because we should understand the accuracy here is essential for proper radiation calculations, RAW estimation, and radiation safety assessment. And also, it's very important for economics, for budget, to avoid overruns and underestimation of our budget. It's one more example. And as I mentioned, when each element has its own specific activity, we can generate project documentation. You can here see our project documentation. If we are talking about the project documentation, on the slide we can see characteristics, plans, views, and characterization data. Because of planning stage and analytics, even before his work process, our specialist knows where he goes, he understands his tasks, we understand how many specialists we need, what equipment do we need, what kind of equipment, safety equipment do we need beforehand. And here we move to the next set of technologies. There are some critical factors during our work. For example, many facilities can have contaminations, strong radiation contamination, and it's a limit for human operations. So it can be solved with using unnamed technology like drones or robotic platform. In our company, we use both drones and robotic platforms. This is concept idea of a group of drones application for physical and radiological survey. Each small drone equipped with a sensor. It could be a portative laser scanner, dose rate measurement tool, alpha beta counter. Each drone has its flight route developed to cover the most possible area. All drones are equipped with in-house laser navigation system powered from the base station, independently from GPS, independently from satellite navigation systems. And drones scan the target area to obtain the point clouds, which then are used for building beam model. Here drones perform the radiation measurement. Anyway, all the collected data in real-time mode transferred to the base station and then to the beam model. And second technology we apply for automatic data capture is smart robotic platforms. This robotic platform is in dog shape, and it has 4 legs from Deep Robotics company. The robot equipped with laser scanner, panoramic camera, and dose rate measurement tool. We tested the ability of this robot to move through complex facility, such as stairs. Stairs. Voila. And he proved this ability, declared ability. In the test mode, the robot was remotely controlled, but in general, it can work in autonomous mode navigation through computer vision or preloaded beam model. Here we can see the result of laser scanning and panoramic capture performed by our robot. Using beam software, we can navigate inside the integrated point cloud of scanned area. As you can see, the accuracy and resolution of scanning is very high. So we can see wires, we can see elements, attributes. I can choose every element and for example, here we have violet cylinder. I can choose this little element and I see the attributes, the list of attributes here. It's very convenient. And as I mentioned, the accuracy is very high. So we can see all elements and the centimeters of elements. It's also very convenient. And we can perform analytics work because of 20 kilograms of measurement devices carried by our robot. Here it's briefly the summary of my report, and I would like to draw your attention on the practical example. You can start, Oleg. You can see this robot I mentioned in my report. He's a director from nuclear power plant. To see you here. He also has like summer holidays with you. He can jump, but he preferred dancing mode. Not. He's very serious. All idea in his hand. You can make photo all together with these robots if you wish. Yeah. Do you want to have maybe the photo of the group? No?
Let's make photo. Yes.
А что ты хочешь?
На стол поставить, я не знаю. Главное, что...
Может, его выключить, и как вот мы с тобой его переносим лучше, нет? Или ты под брюшко хочешь взять? Лучше да, он как бы будет такой. А я могу сверху на ступенечку, нет? Пойдем тоже сфотографируемся. Мне кажется, нас кто-то может сфотографировать из... Здесь. А вы кланялись? А, уже кланялись. Кланяться тоже умею. Thank you very much.
Okay,
For your
let's
attention.
thank the speaker and and the dog and the operator again. What is the mass of equipment? Массу
20 kilograms.
20 kilograms. Okay.
But not for this model. It exists bigger one, and for bigger one it's 20 kilograms, and for him maybe 5 or 10 maximum.
Okay. Можно пройти магазин.
Maybe in 1 or 2 years.
На каком расстоянии можно контролировать?
Вот это мы не спросили. It's special control, special device, but we don't know about the distance. Maybe it's 100 meters. 100 meters, it's possible. 100 meters, it's possible, I suppose. But to go to the shop, it's to know.
Yes, very thick. Is it radio controlled or by internet?
You can control by internet by preloaded beam model, for example. Yes, and it's not very cheap decision. It's 20 million rubles to go to the shop. So I don't know.
It's not safe for the dog. Okay. Any more questions?
Hello. Thank you for the presentation. For another question, I learned press. What equipments can you install on it? You showed us like lidar, acoustics, sonar systems, radiation measurements.
Radiation measurements only.
So you can integrate many things all together, or you have different type of docs with different tasks?
No, it depends on tools. He can have different tools, cameras, different measurement tools, counters, alpha, beta counters. So 20 kilograms of tools.
So they can be placed together.
All together, yeah.
Maximum 20 kilo of capacity. Detectors, I think is fine for sodium ion.
I have also one question about the attribution of the objects after the scanning. So there is a scanning procedure, and then this attribution is made manually by the operator, or it is some automatic system for the recognition of the objects.
Automatic system.
Automatic.
But our specialists, they verify the result, but it's automatically now,
Okay.
21st century.
Okay. So it is some sort of artificial intelligence of...
Yeah,
okay.
yeah, artificial intelligence tools help us a lot.
Okay. Okay. Is it Russian software or?
The software is Russian. The robotic platform is Chinese. But now I know that in Russia there are a lot of works to develop also Russian robotic platform.
Okay.
If we talk about drone concept, it's Russian.
What is the plan, the time schedule for this drone system?
2 or 3 years.
2 or 3 years.
Wait.
Okay. Do you have already some examples, some few drones to test them?
No, but we work hardly with many universities in Russia. Maybe in next year.
Okay. Okay.
So if you are planning to send it to the nuclear power plants for decommissioning operations where they have the high activities, I think they need a radio protection for the dog as well. It will get also contaminated. So do you have any measures against that?
Yeah, each dog has his own costume
Okay.
to protect him, it.
Will be heavier. Okay. And I see that these systems, they're very convenient for the planning. You showed us that it is possible to see how these radiological risks and these dose rates are changing when you remove some parts of the equipment. And I think it's very important for the planning. You just can see in, let's say, in online how you so if you move this part, how will the situation change, or this part, and how to plan the removal or dismantling of the certain parts from the facility. It's I think it's very important. Any more questions? Yeah.
You said that this robot can be used in decommissioning activities, and during decommissioning activities, there is a lot of radiation in the environment. There is a camera installed in the front of this robot. Is this camera radiation resistant or not? The camera on the robot is radiation resistant. How much radiation it can resist? The camera on the robot.
It's too difficult question for me. Maybe you have to visit our office to talk with specialists about the contaminations, about levels.
Yeah, I'm not sure that. Of course, it depends on the facility. If it is like a high-level waste repository or highly contaminated, like I don't know, Chernobyl nuclear power plant, maybe it makes sense about this radiation stable or resistant cameras. But for typical facilities, I'm not sure that it is so important. But yeah, I think it really depends on the facility. Yeah, I know. Oh, okay. But yeah, maybe they have some solutions, the specialists. Okay. Thank you. Any more? No, if not, then let's thank the speaker again. Thank you for your
Thank you.
presentation and for for your dog. Yeah.
With all your developed digital tools, are we estimating a reduction on the completion of decommissioning compared to the conventional decommissioning activities or operations? Because you already integrate many digital tools to get together and technology for scanning, radiological surveys, and simultaneous radionuclide inventory chains on the way which you also denoted. So there will be. So, are you expecting the decommissioning projects to be completed much earlier than the conventional?
Now we just on our first steps with first and second blocks of Kurskaya NPP. It's a long process, and we don't have many examples around the world. So maybe it's a little bit secret information, but I can only say that we have started.
It's really promising technology.
When we will finish, we will inform you.
Okay. Thank you, Ekaterina, again, and
you, Vladimir.
Oleg. Now we have a small break, and we'll continue. So.
Да, может быть, в следующем году уже какой-нибудь дрон будет.
Это был вообще
Am I to... Shall I start or?
Так, вы нас слышите? А. Do you hear us well?
Can I start?
Oh, yeah, you can start.
Okay.
But your presentation is
What? Is it okay now?
yeah, now it's okay.
Okay. Good afternoon, everybody. I would like to thank the International School on Decontamination or Decommissioning for inviting me to present the activities of WIN Africa, with special thanks to Olga and Andre Putatin. Actually, I attended 2 schools and I did benefit them a lot. And I am happy to be here once more in this class. I'm going to speak about the role of African Association of Women in Nuclear in disseminating nuclear sciences and technologies. Actually, when Africa started in the year 2020, we started with three countries, Egypt, South Africa, and Morocco. And now by the year 25, we have reached about 22 countries and still more 30 countries, because African countries are about 53 countries. So what do? We are an NGO. We work with devotion We work in peace building, provide social services, environmental protection. We share in community development, and we call for human rights. And we combine together women in nuclear. So, what is the role of WIN Africa? Advocating for women in nuclear. As I said before, human rights, peace and friendship, social services, community and environment protection. We provide social services to be visible to the society, organizing charity events, health campaigns, and public engagement activities, supporting local communities through social and environmental initiatives. And we promote public awareness and education about nuclear. We developed a dialogue with the society about the benefits of nuclear technology, and we encourage young people, especially women, to pursue careers in nuclear sciences. We also encourage international collaboration by strengthening partnership between African countries in nuclear education and research, and participating in global forums and discussions on sustainable development and clean energy. We call for human rights because in some countries there is no balance in hiring and in salaries and in letters of recommendation. So we are calling for more gender equality. I will enter one of the aspects or one of the important role of WIN Africa is to develop a dialogue with the public to promote awareness and education of to the contribution of nuclear technologies to the people and the society. Because as you all know, public fear the word nuclear. And now for development, nuclear is needed. Nuclear is needed for power plants. And nuclear applications are vast in food security, in environmental protection. There is a lot of nuclear application which the society, we have to let them learn to accept the word nuclear. How do we develop a dialogue with the public to promote awareness and education of the contribution of nuclear technologies? First, by providing social services in order to be visible to the society. We organize health campaigns, we organize social activities, we organize charity events, and we organize seminar and workshop. Of course, if you make an advertisement there is a seminar on nuclear, nobody will come. So we have to go and make events, and during these events we tell the people and we tell the young people about nuclear and its importance. So I'm going to speak about WIN Africa activities. We participate in global events. We attend the International Agency for the International Atomic Energy Agency, all for its general conferences. We have also attended the Euro-Asian Women Forum held in St. Petersburg in September 2023. We make excursions in places in Egypt, because each country has its own chapter, and every chapter does its activities in the country. So in Egypt, we make excursion to the White Desert, we make Ramadan iftar, and we make webinars and seminars on different aspects of nuclear technology. We make health campaigns and these campaigns are in collaboration with the Ministry for Health and Population, and we did a lot of campaigns on virus C and liver diseases, because these diseases are endemic in Egypt. We make health campaign on kidney diseases and hypertension. We make on diabetes and control of obesity, and we make early detection of colon and cervical cancers. And during the COVID, we made a campaign so that we can. It was difficult to go to health centers and have the COVID immunization because it was very crowded. So we arranged for immunization of the workers at the Egyptian Atomic Energy Authorities and their families at their workplace, where the people from the Ministry of Health and Population will come and give them their immunization. We made a health campaign on osteoporosis. And usually when we make a health campaign, we make a seminar, and we bring professors from the universities to give their experience on the diseases, its prevention and early detection, and to encourage people to come to the campaign. We made a campaign on osteoporosis. And during this campaign, we brought boys from a near school so that to see the event. And during this campaign, we spoke to them about nuclear and its importance. We also make health campaign on breast cancer every 2 years. We bring a van from the Ministry of Health and Population, which is equipped with a mammogram and equipped with what? And equipped with a mammogram, and in order to make early detection for women. And we opened the doors of the Egyptian Atomic Energy Authority to the public so that they may come and have this service for free. The car is equipped with a sonar also, in addition to the mammogram. The ladies will have their test, and if anybody was detected to have the diseases, they will be transferred to the ministry, and there they will have all the tests and all the needed treatment and operation for free too. One of the environmental projects we have shared, it was in a collaboration with the Ministry of Environmental Affairs. People throw plastic waste in the River Nile, and these plastic waste come and aggregate at we have across the River Nile something called El Qanater. These are structures to prevent the waste of water to the sea. So at this conjunction, plastic will accumulate, and so we made an excursion, and business people provided us with transportation and boats and special dresses to go to these places. And we took children, and we took also university students, and we went to this conjunction, and we started gathering the plastic waste. After that, the plastic waste goes to ladies, or they are treated. They are of course washed and treated and changed into beads and given to ladies as handcraft, where they make products, as you see, bags and these are handicrafts provided after the washing and recycling of the plastic waste we gathered from the River Nile. We also had a sport event. We joined with a team of men. Actually, in Win, Egypt, we accept men at our society. So we went to one of the Ramadan contest on football, and we won the cup. We also, Win Africa is also represented in many of the IEA events. We shared at the opening of more women in nuclear, which was held on the occasion of Women's Day. And we make webinars with AFCON and the International Atomic Energy Authority. AFCON is the African Commission for Nuclear Energy. We also shared in the youth forum held in Alexandria by Rosatom. I attended Women in STEM in Moscow in 2023, and we attended many events in South Africa. We also shared, in Africa, shared in COP27, which was held in Egypt, November 23, and in COP28, carried out in Dubai, 2024. There are challenges in Africa for women to work in nuclear. These are because of early marriages, violence against women, and more school girls are needed because girls do not, they start at the primary school and usually they do not continue. And also the impact of climate change on women, especially in the rural area. As you see, Africa is hardly affected by the climate change and the increase in temperature. We can see that the Lake of Chad has shrinked. The glaciers at the mountains have decreased, and this decreases the input of rivers providing water for Africa. There are fires, and people are suffering from the loss of livestock, desertification, and so many. And this increased the immigration of African from their places to other places. And this has a very bad impact on women. I would like to speak about some of the chapters of WIN Africa. We have the South Africa WIN chapter. This is a very active chapter. They go to universities, they go to school, and they have organized what is called Girls in Nuclear. And all this is to increase the number of women working in nuclear and disseminate to the society the importance of nuclear. They also go to schools. They go and make their food one of the days and share in the cleaning of the schools. And one of their projects was to go to school and to plant the school. And of course, they would get in contact with the children. I have also WIN Ghana. WIN Ghana is a very active chapter. They go to schools and they go to universities in order to disseminate nuclear to the society. I have also WIN Democratic Republic of Congo. This is also one of the active chapters. They make webinars to the Congolese people, and they make also campaigns. WIN Niger cares a lot about health campaigns, especially for breast cancer campaigns, and they make this breast cancer campaign every 2 years. Thank you.
Thank you for your presentations. Are there any questions?
شكرا دكتورة سهير.
أهلا بك.
Thank you, Dr. Sair. I am Mohammed Ghulim from Nuclear Materials Authority of Egypt and senior researcher in Joint Institute of Nuclear Authority in Russia. I just wanted to thank you for the presentation and say that we are proud of you and proud of your success in women in the nuclear. And I wanted to have opportunity or chance to meet you in Egypt or in any place. Thanks
Well, I'll be
again.
proud to meet you, and you can take my phone number from Olga, if she can
Okay.
kindly give it to you.
Okay, thank you very much. Thank you.
Thank you so much for your lecture. So I see from your lecture that you said the organization started in 2020, if I'm correct.
Yes.
Okay. So I didn't quite get the aim of your organization. I don't know if you could highlight them once more. Secondly, I don't know if your organization have been able to maybe pinpoint some of the challenges why African countries have not fully, let's say, embraced or implemented a nuclear, the use of a nuclear power plant. But currently, I think there are just two countries, Egypt and South Africa, that are maybe using the benefits or advantages of nuclear power plant. Why have other African countries not yet embraced these benefits? Thank you.
I think it's the economic. To build a power plant, you need a lot of money. And actually, there is a lot of African countries on their way for nuclear power plants in Zimbabwe. I think they signed a contract. Kenya is trying, and Burkina Faso wants to make one. But the problem, it is of course a governmental decision, and it needs a lot of money.
Okay. So I'm sorry I had to ask this again. To your organization, do you have like any form of advocacy program to, challenge other African countries, especially African leaders? Because I don't, I know there are a lot of money required, but I think some African countries have the willpower. Maybe if you do more of advocacy to these African countries, and maybe they may be able to embrace implementing power plants.
Well, our power plants are very important for sustainable development, and and it is important for industrialization and agriculture. And in countries where there is no sources of water, power plants can make desalination. So power plants are very important and are very important for Africa development.
Okay, thank you.
But you are speaking about countries which have very lately received their independence. You see, Africa was mostly colonized. So once they get their freedom, they are on the correct way. And I think Africa is developing, and there is a lot of women, maybe more than in European countries, are interested in working in nuclear.
Okay, thank you.
Dear Suhir, I have no question. This is Olga speaking. I would like to use this opportunity to thank you very much for participating online, for giving us a lecture. And I'm also very grateful to John raising a very, very important question regarding the future development, regarding the future of Africa. As for myself, I truly believe that future belongs to this Black continent, and through our schools I've met a lot of enthusiastic young people from Africa, and ladies included, of course, very active and talented ladies. And I truly believe that these young people gaining knowledge from here, from Russia, and not from Russia only, but in our case from Russia, will determine the face of their nuclear industry of their countries in the future. And I see personally a huge potential in your youth, in African youth. So once again, dear Sohair, once again, this is a great honor for us that you gave us a lecture. And of course, I will be more than happy to see you again in Russia. Thank you very much.
Bye-bye. Thank you. Thank you, Olga. I'm very happy to hear your voice once more.
Thank you, Sohair. Any more questions, dears? No? Thank you. Thank you. Thank you. Thank you very much.
Bye.
Bye-bye.